is, are you influenced by others when rating? Improve rating prediction by conformity modeling.
Hi everyone, I'm Xuezhi from Shanghai Jiao Tong University, and I'm going to introduce our work improving rating prediction by conformity modeling. First, let's recall the concept of conformity. People normally tend to follow the others, especially the majority when engaging in a society due to social pressures. Therefore, conformity shapes people's behaviors to group norms. Such phenomenon widely exists in almost all decision-making processes, ranging from political voting to daily dinner choices. There have been tremendous social psychology researches in this direction. Various experiments are carried out to demonstrate the existence and to study the strength of conformity. So the following question is whether conformity exists in online scenarios. Users in online environment are flooded with others' opinions. Tweets, reviews, comments are all over the internet. Intuitively, these opinions must have some influence towards the audience opinions. However, on the other hand, the internet is a rather anonymous environment compared to the traditional society, where the social pressure is reduced and the users are supposed to express their truthful thoughts freely. So the strength of conformity might be limited. So analytical or experimental supports are required to answer this question. Fortunately, the opinions and actions in the online environment are well documented as logs, which provide perfect data for conformity analysis. In this paper, we will focus on conformity in rating sites. Rating actions are considered as a perfect quantifiable expression of one's opinion towards the items. And in rating sites, users are aware of the public opinion towards the item before each rating action. Such opinions are normally highlighted on the items page, which gives the aggregated rating, the rating distribution, as well as the number of raters for the item. So we first conduct preliminary analysis to show the existence of conformity in movie rating sites. We represent each rating log as RK-PK pairs, where the RK indicates the rating score given by the user, and PK indicates the aggregated rating for the item right before the user takes the rating action. If online conformity does not exist, then the RK and PK should be independent. Here we show the relation between RK and PK for two randomly selected movies here. Clearly, they are not independent with each other, which indicates the conformity do exist in online rating sites. Existing user modeling techniques, for example, matrix-factorization for the rating site scenario, does not consider the conformity phenomenon and models the user action purely on the user preferences and item characteristics. When making predictions, traditional models directly predict based on the preferences modeling. To take the conformity phenomenon into consider, we propose the conformity model, which takes in both the prediction of the preferences modeling as well as the public opinion as input, and output the final prediction on the user ratings. First, we consider a simple linear conformity model, which models the final prediction as a linear combination of the preference-based estimation and the public opinion. This model is parameterized by omega, which can be viewed as a conformity strength. Setting omega to 0, the conformity model will be degraded into the traditional preference-based approach, and setting it to 1 will be simply predicted by the public opinion. The key in conformity modeling is the selection of the conformity strength. Manually setting it by hyperparameter does not provide a solid solution. Existing researches in offline conformity tells us that factors such as group size and cohesion may affect the level of conformity an individual displays. Therefore, we aim at modeling these factors for the conformity strength. First, let's consider the group size. For the rating size scenario, the group size will be how many users have rated the item. We model the conformity strength as a function of the group size. Due to the property of conformity strength, We need the function to be a nonlinear monotone increasing function with constrained range. Also, we prefer to test a tipping point to model the threshold of group size. To satisfy this requirement, we chose the sigmoid function with linear transformation on the scale. Then we try to model the cohesion. For the rating scenario, the rating distribution is the indicator of the cohesion. For example, both these movies have an average rating of 3.5 stars with different rating distributions. Intuitively, the rating distribution for the first movie will lead to a rather strong conformity strength comparing to the second. We employ gradient boost decision tree for the cohesion modeling. We use it because it can capture complex and nonlinear relations, which should be the case for the cohesion modeling. We employ XGBoost as the implementation for that. Now I will introduce the experiments and the result. To show the performance of our conformity models, we evaluate it by rating predictions. We employ mean absolute error and rooted mean square error as the key matrix. We compare it with several traditional preferences-based methods, such as probabilistic, matrix-factorization, and SVD++. Here we show the results as well as the relative improvements in this table. Our final model, the conformity model with the cohesion, has an improvement of around 10% over the best preference-based model, indicating that by conformity modeling, we can actually improve the user modelings, as well as the recommendations based on it. So that will be all for my presentation. Thank you for your attention.
Questions?
So that's a very interesting subject. I'm not sure, I think you said it, but I'm not sure I understood. How do we distinguish between conformity and, say, one item being genuinely better than the other?
Well, for one item, the aggregated rating will be different at different timestamps. So we have shown that users under different times with different aggregate ratings shown to the users, they have different average ratings towards items. So it will answer your question, I think.
So just to maybe clarify, so was this under some sort of experimental conditions where you sort of were able to?
Nope, it's not under experiment. Okay. It's just
So sort of the assumption is that users most likely were aware of the rating, right?
Yeah.
Because if they were not,
yeah, that is
then
the
there's
assumption.
No conformity, right? I mean,
yeah.
Okay.
Because on each rating site, you must conduct the rating on the items page, mostly, I think. And on the items page, we have the aggregated ratings as well as other public opinions.
Other questions? Okay, let me ask one other quick question. So, so now it seems based on this research that, again, you can predict, the rating gets affected, right? Because
yeah.
Including conformity modeling, you have a better prediction accuracy,
yeah.
right? So obviously, why we predict ratings? We predict ratings because we can show them to the users later as recommendations, let's say, right?
Yeah.
So now is it better to show your affected rating to the users, or maybe is it better to somehow use the conformity modeling, perhaps using your approach or something similar, and perhaps subtract that from the, and then use that as a recommendation? Because otherwise, predicting the affected rating may not be the best practical.
Yeah, for recommendations, we should consider to extract the effect of the conformity. And based on that extracted rating, we should consider to recommend what items to the user. But we cannot do directly experiment on that. So in this work, we just test it out for the rating prediction task.
All right, thank you very much.
Thank you.